Lesson15.1 Newton's Law of Universal Gravitation. Gravity is an action at a distance force. This means that two objects don't actually need to touch in order to experience the force of gravity between them. For example, the moon is gravitationally attracted to the Earth, but the moon and the Earth are not touching. Gravity is the force of attraction between any two objects with mass. As far as we know, there is no repulsive version of gravity. Gravity is always attractive. Newton came up with a formula that allows us to calculate the gravitational force between any two objects. This formula can be used anywhere in the universe. It doesn't just have to apply to objects on Earth. The formula is Fg equals capital G m1 m2 divided by r squared. We'll talk about what each of these pieces are in a minute, but it's important to know that this is called Newton's Law of Universal Gravitation, and it's one of his most famous works. This formula allows us to calculate the gravitational force between any two objects with mass. m1 and m2 are the mass of the two objects. R is the distance between the centers of each object. Now remember that Newton's third law says that for every force there's an opposite and equal reaction force. This means that the two objects pull on each other with opposite and equal forces of gravity. So Fg is the same no matter which object you're looking at. Capital G is a constant. A constant is a number that's inserted into a formula to make the formula work. We call G the universal gravitation constant. It's called universal because it works anywhere in the universe. Unlike little g 9.81, which is true only on Earth. Very important, do not confuse capital G, which is universal gravitation constant, with little g, which is the acceleration due to gravity on Earth, 9.81. They are not the same. Even though he came up with the formula, Newton never found a value for G. A scientist named Henry Cavendish found a way to measure G, but it was much later, almost 100 years. G is equal to 6.67 times 10 to the minus 11 Newton meters squared per kilogram squared. Don't let the unit throw you, it's just a unit. This constant is found on your formula sheet under the constant section. Example. What is the force of attraction between an elephant, which is 2,000 kilograms, and a supertanker, which is 15,000 kilograms, when they are 50 meters apart? We use Newton's law of universal gravitation. Fg equals g m1 m2 divided by r squared. This is 6.67 times 10 to the negative 11, capital G, times 2,000 times 15,000 divided by 50, which is the distance between them, squared. Be careful with the r, don't forget the squared, it's a common mistake. This gives us a force of gravity equal to 8.0 times 10 to the minus 7 newtons. Here's another example. Two objects have masses of 5.0 times 10 to the 8 kilograms and 6.0 times 10 to the 8 kilograms. How far apart are they if their gravitational attraction is 500 newtons? We start with the formula Fg equals g m1 m2 over r squared, and rearrange this for r squared. R squared equals g m1 m2 divided by f. Solving this for r, we get the square root of g m1 m2 divided by f. This gives us r equals the square root of 6.67 times 10 to the minus 11 times 5 times 10 to the 8 times 6 times 10 to the 8 divided by 500 newtons. This gives us an R equal to 200 meters. Gravitational forces add as vectors. Like all forces, if you want to combine them, you have to use vector addition techniques to add them. Example. We have three objects, A, B, and C. A is 2 kilograms, B is 4 kilograms, and C is 3 kilograms. The distance between A and B is 3 meters, and the distance between B and C is 4 meters. Find the gravitational force on B. Now B is attracted to both A and C. We have FGA towards A and FGC towards C. The total force on B is going to be the vector combination of the two. First, we need to calculate each force. FGA is G, mass of A, times the mass of B, divided by RAB, the distance between them, squared, which is 6.67 times 10 to the minus 11 times 2 times 4 divided by the distance between them, which is 3 squared. This gives FGA equal to 5.93 times 10 to the negative 11 newtons. This is to the left. FGC equals G MC MB divided by RBC squared. This is 6.67 times 10 to the minus 11 times 3 times 4 divided by 4 squared. This gives 5 times 10 to the minus 11 newtons to the right. The total force of gravity on B is going to be FGA plus FGB, or FGC, but remember that these are vectors. Since A is to the left, it's negative. Negative 5.93 times 10 to the negative 11 plus 5 times 10 to the minus 11 gets us an FG equal to negative 9.3 times 10 to the negative 12 newtons. Writing this in correct form, we get FG equals 9.3 times 10 to the negative 12 newtons to the left. Another example with somewhat harder vector addition. Now A, B, and C are the corners of a square. A is 2 kilograms, B is 3 kilograms, and C is 4 kilograms. The distance between A and B and the distance between B and C are 2 meters and 3 meters. What is the gravitational force on B? B is attracted to A, and we call this FGA, and it's attracted to C. We call this FGC. FGA is G, mass of A, times mass of B, divided by the radius between them, RAB squared, which is 6.67 times 10 to the minus 11, times 2 times 3, divided by the distance between them, which is 2, squared. This gives us 1 times 10 to the negative 10 newtons to the left towards mass A. FGC is G MC MB divided by R BC squared, which is 6.67 times 10 to the minus 11 times 4 times 3 divided by the distance between B and C, which is 3 squared. This gives us 8.89 times 10 to the minus 11 newtons down. Now we have to combine these two forces using vector addition. FGA is to the left, and FGC is down. This means these are two vectors at angles, and we need to add them using a right angle triangle. FG is the resultant of the right triangle formed between FGA and FGC. So FG's magnitude is the square root of FGA plus FGC squared, which is 1 times 10 to the negative 10 squared plus 8.89 times 10 to the minus 11 squared, which gives us a magnitude of FG equal to 1.34 times 10 to the minus 10 newtons. Since it's a vector, we also need to find the angle. Theta is tan negative 1 FGC over FGA, which gives us 84 degrees down of left, which means the force of gravity is 1.34 times 10 to the minus 10 newtons at an angle of 84 degrees down of left.